Friends, today I am going to discuss expectation value of an operator in quantum mechanics. Expectation value for beginners uh, of expectation value of an operator in quantum mechanics. Actually, in quantum mechanics, many of students are facing problem. Many of students face problem to do the expectation of an operator. So let's start discussion and let's make it crystal clear how to do expectation value of an operator. So first of all, you all know the operators. Suppose what is operators? Operators actually that represent any physical quantity or any observable. You can say observable, physical observable or physical quantity that can be measured. Actually, that is actually Hermitian operator. All physical observable are actually Hermitian operator. So that's not our topic to discuss today. Today our topic is how to do the expectation value of an operator, whether it is odd operator and even operator. Means operators can be of two types, no? Means operators can be two types. That is odd operator. Another part is even operator. So let's discuss about that. So to discuss that operators, actually we have to know the odd operators and even operators, and to discuss odd operator and even operators we have to discuss today the parity operators in quantum mechanics also. Okay, so let's start discussion. Actually, what is expectation? Let's change me the pen color. What do you mean by expectation? So how to do expectation in quantum mechanics? Actually, what is expectation? Suppose we are taking expectation of a physical quantity, suppose x. Expectation means, in general, it is actually average. But how to represent it in the quantum mechanics? We know that average means what? Average means there are few more some quantities, x1, x2, x3, xn, in number of terms. So average means x1 plus x2 plus x to the power n divided by capital N. This is actual general average without discussing quantum mechanics, without knowing quantum mechanics that we have done. But how to do the expectation value in case of quantum mechanics of any operator? Suppose let us discuss x is an operator. So how to do the expectation value of this? And how to know it is odd operator and even operator? Actually, what is odd operator and what is even operator? Actually, when an operator, odd operator, suppose let us consider an operator A, when it will commutes, and let us consider another operator B that is even. Okay, so let me proceed another way. We don't know what is odd and even. Suppose you have an operator A. So how do you know that it will be odd or even? So the knowing process of even and odd operator is, if an operator is even, an operator will be even if it obey the relation pi operator is parity operator, pi equals a. That means if an operator commutes with parity operator, pi is parity operator. So to discuss it, we will discuss parity operator in details in another videos. So an operator which will commutes with parity operators, that is actually the odd operator. So what is that is actually even operator. The operator that commutes with the operators, the operator that commutes with parity operator, that is actually even operator. And what is odd operator? Odd operator is that if an operator is odd, suppose pi is an parity operator, parity operator has eigenvalue +1 and -1. Okay, for pi +1 and -1 for mixed state. Okay, so an operator is odd operator, pi equals minus of a, so it will be odd operator. So it's another matter of discuss. So we'll discuss in the next video about the parity operator and etc. all. But today our discussion is about how to do the simple expectation, how to take the expectation of an operator. Actually, I think I should take the lectures firstly on the operators and the parity operators, whatever. Then I should take that expectation value of an operator, but no way. So first, let us discuss how to do the expectation. So whenever you are taking expectation of an operator A, so expectation means an operator A has eigenvalue. Suppose an operator A is acting on an wave function or eigenstate ket psi, and it is producing an eigenvalue lambda ket psi. Okay, so this has eigenvalue lambda, and it has eigenstate ket psi. So how can we write the expectation value of this operator? So expectation value can be written in general form. In general notation, expectation value can be written as psi brash I a ket psi divided by brash I ket psi. So this is the general formula or general quantum mechanical formula to obtain the expectation value of any operator. So where psi is the eigenstate of that operator, and if the psi is not normalized, then we can write in this form. If psi is normalized means brash I ket psi, inner product of brash I ket psi equals 1. Sorry. So then it can be written as psi a ket psi. So let's take an example how to do the expectation value of an operator. So in our previous video we have discussed about 1D box. 1D box we have discussed. So in case of 1D box, for symmetric 1D box, so let us discuss about the symmetric 1D box. But before discussing that example, we will discuss another mathematical format of that expectation value of an operator. So we have discussed that operator expectation value can be represented as psi a psi brash I ket psi. So in another way, it can be written as in the probability format. Suppose you have an eigenfunction such that it is denoted as C1 phi 1 plus C2 phi 2. Okay, C1 phi 1 plus C2 phi 2. Now you want to do the expectation. Sorry, let me erase it. Now you want to do the expectation in this state. Actually, here what is psi? Psi is a mixed state or superposition state. So how to do the expectation in the case of superposition state? C1 is coefficient, and C1 mod square is what? C1 mod square probability C1 mod square probability, and C1 is probability amplitude or coefficient. So how to do expectation in case of superposition state? Actually, when we are discussing A average in the individual state psi, then we can say that A average can, or expectation A can be written as psi A psi divided by psi brash I ket psi. But here psi is what? Psi is individual state. Okay. But when we have the eigenfunction, psi for not individual state. Suppose it is in the superposition state. Superposition state means that here probability of remaining in the state ket phi 1 is C1 mod square, that is equals P1, and probability in remaining the ket phi 2 state is C2 mod square, that is P2. So when the function is in superposition state, so how can we represent the eigenfunction? How can we represent the expectation value of an operator A? So expectation value of an operator A in the superposition state. So it can be written as summation over C mod n square phi n divided by summation over mod C n square. This is the form. That means here n value equals 1, 2, 3, 4. So mod C1 square, actually the probability corresponding to that phi n state, and Cn mod Cn square equals mod Cn square will be 1 n. So let's take the example of an individual state. Suppose you have an eigenstate, superposition eigenstate, that is C1 phi 1 plus C2 phi 2. So how can we write A average? We can write A average as mod C1 square phi 1 plus sorry, actually I have to correct the formula actually again. So A is an operator. If we take expectation of that operator in an superposition state C1 phi 1 plus C2 phi 2, then how can we represent it? So we can represent it in such a way that, so A, expectation of A can be written as, let's write in another slide. So expectation of A can be written as C1 square into phi 1 A phi 1 plus C2 square into phi 1 A phi 2 plus divided by, summation over divided by C1 square plus C2 square. So this is actually how can we write the expectation of an operator in the superposition state. So in general, let me correct it. I have written little bit wrong in in general slide. How can we represent expectation in the way of probability amplitude square? So you can write for expectation of A in case of what? Expectation of A in case of superposition state, it can be written as, so we can write A expectation summation over n mod Cn square into An divided by summation over n mod Cn square. So here mod Cn square means what? Mod Cn square is the probability amplitude of the nth state, and An is what? An is actually, let me write. So first let me write Cn square. So here Cn is what? Cn is actually Cn can be written as brash I ket phi n. So Cn mod square will be what? So mod Cn square will be brash I ket phi n square. So that is actually mod Cn square. So we can conclude that in case of individual state, A can be written as, expectation of A means expectation value of A can be written as, in case of individual state, A expectation, that can be written C1 square A1 plus C2 square A2, this is the case of superposition state. In case of individual state, it can be written as brash I A ket psi divided by brash I ket psi. So in case of, it is case of individual state, but in case of superposition state, how can we write? So in case of superposition state, expectation value can be written as, in case of superposition state, expectation value can be written as A average equals summation over n mod Cn square n divided by summation over n mod Cn square. So actually n is what? N will be here, N is actually brash I ket phi n, and this is actually N, not brash I ket phi n. An is actually operator of phi n A phi n, expectation of A in the state of phi n, that is actually An. So let's take an example so that you will be cleared about this. Suppose you have a and before taking example, we can conclude that as P1 equals mod C1 square, similarly Pn equals what? Pn equals mod Cn square. So we can write another format, expectation value, another format we can write P1 E1 plus P2, P2 actually it is the probability, E2 plus here not E2, P1 A1 P2 A2 divided by P1 plus P2 plus up to nth state. So this is actually the expectation value in case of superposition state, this is how we can write. So let's take an example. So in case of 1D box, let us consider it. So let us consider an 1D box 0 to L length. Okay, infinite square well potential box. So the potential of that 1D box is such that the state of that box, state of the particle inside the box is, that is actually 2 by 3. Let us consider 2 by 3 ket phi 1 plus 1 by 3 ket phi 2. So this is actually the state of the 1D box. The state of the 1D box. That's how the particle inside the box is trapped in that state. In this superposition state, the particle is trapped in this superposition state. So now you have to work out the expectation value of x. So expectation value of x means actually you have to work out expectation value of the position operator, that is odd operator, expectation value of the position of the particle inside that box. So how can we calculate this? We will not calculate totally. I am just showing you the process. So the state is such that 2 by 3 phi 1 ket phi 1 plus 1 by 3 ket phi 2. Okay. Now what is actually phi 1 and phi 2? So phi 1 and phi 2, if the box, let us consider the box is antisymmetric for our convenience. Let us consider the box is antisymmetric. So phi is root 2 by length, let us consider length of the box is L. Sine, it is actually the ground state, n equals 1, the ground state of the 1D box, and phi 2 represent first excited state of the 1D box. Okay. So sine pi x by L, phi 1 is actually represented in the 2 by L, sine pi x by L, and phi 2 is representing root 2 by L, first excited state, sine 2 pi x by L. So how can we write x average in that? That means how can we write the expectation of x in that case 1D box, that is actually superposition state. So C1 square, what is C1 there? C1 is 2 by 3 and C2 is 1 by 3 there, as there it is given, as the wave function is such that 2 by 3 phi 1 plus 2 by 1 by 3 phi 2. So we can write expectation of x as 2 by 3 mod square phi 1 x phi 2 plus 1 by 3 square phi 1, sorry, here it can be written as phi 1 x phi 1 1 by 3 mod square phi 2 x, let me write clearly, phi 2 x phi 2 divided by 2 by 3 mod square plus 1 by 3 mod square. So again I am concluding that how can we write that expectation of x? So expectation of x can be written as, in that case expectation x can be written as 2 by 3 mod square c1 square into phi 1 ket x phi 1 plus 1 by 3 mod square phi 2 ket x phi 2 divided by 2 by 3 mod square plus 1 by 3 mod square. So this is how we can write the expectation value of x in that case of a 1D box. Now the matter is how can we represent in the expectation of x in case of 1D box. So phi 1 x phi 1 means actually what phi 1, sorry, why I'm writing phi 2, it's actually phi 1 it will be. So phi 1 will be phi, that is root 2 by L sin x n pi x by L. So actually in case of 1D box, expectation value, just now calculate integration 0 to L root 2 by L sin pi x by L x into root 2 by L sin pi x by L. So that's not our concern, that's actually the calculating part. So just to do the introduction, just we are discussing the how can we write the expectation of an operator in an individual and superposition state. So the conclusion is, let's write me the conclusion. So what we learned today. So when we will take the expectation value in case of individual state, So in case of individual state, how can we write the expectation value? We can write the expectation value as A average can be written as brash I, A cat shy, brash I, cat shy. So expectation of A in case of individual operator shy, A cat shy, divided by brash I, cat shy. Expectation of A in case of superposition state, individual state, not individual state, superposition state. Expectation of A in case of superposition state, it can be written as expectation A equals summation over n mod Cn square n. Let me write clearly. So in case of superposition state, expectation A will be written as summation over n mod Cn square n, summation over n mod Cn square. So what is mod Cn square? Mod Cn square is actually mod Cn square equals brash I cat phi n mod square, and an is actually what? An is actually phi n a cat phi n, brash phi n a cat phi n. So this is how we can write the expectation of A in case of superposition state. In the probability format, expectation A can be written as summation over n Pn an divided by summation over n Pn. So Pn is actually what? Pn is actually the probability corresponding that state of corresponding to n state. An is actually what? An can be written as An is actually that phi n a phi n. So this is how we can write the expectation of any operator in case of any eigenstate, individual eigenstate, and in case of superposition eigenstate. So this is the introductory thing. So one thing in our next video we will discuss about the parity operators and how what is the expectation of odd operator, even operator. We will discuss about that also, what will be the expectation of odd and even operator. So thanks for watching patiently. Thank you. That's it for today.